Hey knife makers, Tracy here at USAKnifemaker.com. Today we're going to do a quick run through on how to attach scales to a heat treated finished kit blade that we have in stock. We're going to use some G10 or micarta today, and we will fasten that onto our kit blade. These come to us in, we get these in heat treated, ground, ready to go. Basically what you need to do is simply fasten on some scales to finish off the handle. Like that. We'll pin those on, and we'll also use some Corby bolts and glue those on, remove the excess, and we'll have a finished knife. This particular blade kit is a bushcraft model that we had, it's our design. We had it sourced with USA steel, with USA finishing on water jet, heat treating, grinding, that kind of thing. So this is an all USA blade. We also carry a pretty wide assortment of blades that we import from China, and like it or not, China business is here to, it's just a piece of the global economy. You can choose not to buy them and find some USA equivalent, that's great, but we've got a pretty wide assortment of those, and this kind of tutorial is going to apply to those also. Here we have a fishing fillet knife. You put your handles on there, round off the sharp edges, cut it back to match the outline of the handle, fasten and glue those on, and you've got a finished fish fillet knife. And all of these that we have here are made in 440C, which is a great steel. It's probably the most popular knife steel in the world for a reason. It's economical, has great corrosion resistance, holds a pretty good edge. You can sharpen it pretty well, and it's tough enough not to chip out when you use it. So let's go ahead and get started. Let's go over some of the handle material selection choices that we have. We have quite a variety of different materials that you can choose from to put on your kit blades. We'll take a look at some of this material. We've got dozens of different kinds of G10 in colors. G10 is a fiberglass material, and some of it we have custom made. This is a particular one that we have custom made for us, and it has the resin is dyed, and the alternating layers will have different colors. And this one happens to be a brown, white, and black. Now here's some in alternating black and OD green. Here you can see one in orange and black. Now the difference between these two is this one's called a 2x2 layer. If we go that way, you can see a little better. Compare those two. That's a 2x2 layer. So there's two layers of glass and colored resin. And here this is a 1x1 layer, and you'll see that the lines are thinner, sharper contrast, more contour lines. Okay. Then we have all different colors, yellow and black, neon toxic green and black, white, orange and black, blue and black. Then we have some of the straight colors, OD green, tan, brown. Here's an antique ivory. It's got some real subtle, nice lines in there as you sculpt and contour. When you get done, it looks very much like a piece of antique ivory. Some nice blue. Green, that's got some dark lines in it to show some additional contrast. Here's a beautiful burgundy with some alternating lines in there, and when you sculpt that out, it really takes on just a great tone. We call this stuff Jade Ghost. It's actually G10 natural epoxy in the trade. And some traditional natural canvas, that's called. Most people in our business call it brown. In the phenolic trade, that would be natural canvas. Then we have some green. Now we also have a product that we're exclusive distributor for in the US called Kiranite. And this is a toughened acrylic, and it comes in different patterns and colors. You can see as you sculpt it, it just takes on just an amazing color palette there. Polishes up beautifully, pretty tough. We actually had some of this in the freezer, threw it down on the ground. Traditional acrylic would probably shatter. This just bounced. So pretty cool stuff. Then we've got some other materials here. We've got bone. This is amber dyed bone, and that's called a Remington cut. Across there, you can see you're going to get it, and it's going to look something like this, that way. Then when you get done sanding it, buffing it, cleaning it up, you're going to get just that wonderful, that deep red amber dye color there. We carry this amber dye bone in different sizes, different jig patterns. Then if you really want to get exotic, some buffalo horn. Then we have, of course, a wide selection of traditional sandbar stag. So lots of choices. I didn't even bother bringing out all the wood. You may have some wood in your backyard that you want to put some scales on. This technique will help you all the way through. So let's take a look and see how we can get some of these scales mounted on. What we're going to do on this kit knife, on this build, we're actually going to do a couple things. We're going to replace these pins, and we'll use Corby's. And a Corby bolt is a two-piece affair. They're threaded male and female part, and they will go together like that. And basically, they will go on either side of the knife, and your handle scales will go on there. We're going to drill holes where in the tang, where those Corby's would be located, or the pins. But in this case, Corby's. We're going to use both on this knife, and we'll fasten those together. And that provides a mechanical lock to hold these scales on. Pretty cool device and really secure way to hold on knife scales. So these come with a major and minor diameter. The minor diameter will be made to fit through the hole in the knife. Obviously this one's too large for this, but we have a micro size actually that will fit this particular hole. And we'll go in there like that, and on the other side we'll screw it together and tighten those up, and we'll grind off the excess as we get through there. We carry these, we have these custom made for us. They're USA made parts, USA sourced material. We have these in 4 sizes in stainless, different major and minor diameters. We call them large, medium, small, micro. I had to call them something. We also make some of these in brass, and we have some in copper. And we've even done some custom machining, and so as a result carry aluminum. So we've got those different things there. And on this kit knife that we're going to do 2 quick pins. These are 3/32 stainless steel. And then we'll use 2 Corby bolts there and there, simply to demonstrate the technique difference between using a Corby and a pin. You're welcome to use either one. You can use all pins in here or all Corby's. In this particular blade style, we have 2 extra holes right up front here for a metal bolster or a wooden bolster, a different color micarta or G10 bolster that you could put on there. And the idea being that you would mount your knife handles right there. And then maybe a different piece of material up there like that. Obviously that wouldn't go there, but you get the idea. So today we're going to elect to fill those in, and we're just going to bring our scales all the way up that way and not necessarily mount a bolster. That's for another time. Okay, so let's get started. To begin with, we're going to locate the holes that we have in the tang here, and we'll get them into our scale material. So we're going to take both pieces of material, stack it up, and we'll put that on the back side. Now we're going to have plenty of overlap. We just need to overlap rather. We want to make sure that we are far away from all the edges. We're going to have a lot more sticking up here. We're going to take and remove that later on as part of the process. I'm going to just use this clamp to hold it in place, and then I'm going to use a C-clamp that will hold it in place quite a bit stronger as we drill. So we have that. Now we're ready to drill. All right, we have a 3/32 drill bit chucked up. We're using a 1, 2, 3 block as a standoff from the drill table so we can get a good grip. We're going to bring that down, and we're going through the hardened material in the knife tang and into the canvas scales. Now, this is a small bit, tends to bind up. That material gets in the flutes, packs in, and you got to clear your chips fairly often, or you're going to end up breaking off your drill bit. So I'm drilling through, clearing out the chips, clean the flutes out so it doesn't bind up and break the drill bit off. We're hitting on one of the holes in the block, and just move that out of the way. You can see where that wants to climb up the drill, so we're having a good grip on that. Let's get out of the way. Now I'm going to put a pin in there, and that's going to hold it in place so it doesn't get out of the way and it doesn't move. We don't want that hole shifting, so we want that indexed all the way through. Actually, I had to go get a hammer and tap that through. What happens when you drill on this material, this particular material, as you drill through and then remove the drill bit, it tends to squeeze shut just a little tight, and so that got a little tight in there. Just took a hammer and tapped a little bit through, so now we can pound that back so it doesn't interfere with our next hole. Flush again, set that to the side, and we're ready to drill our next hole. Okay, we have all of the holes drilled. So these pins, index pins, are still in here, and as I mentioned earlier, this material tends to shrink down and grab these, so getting these out is a challenge sometimes. I grabbed the big vice grips. Try not to stab myself. Pull those out, and finally, that last one. Now, we still have to countersink some holes for our corbies. And as that material has shrunk down, it's closed up the hole slightly, even though we're using the right size drill bit. So what we're going to do is we're going to actually re-drill this material with the next size larger drill bit, and then we'll work on getting a quick countersink in for the major diameter of this corby. We're going to put the pins back in, 2 of them anyway. And then we'll drill out those holes. Those 2 holes that we have remaining right here. Got those 2 holes. We're going to enlarge those with the next larger size drill bit so it's not so tight. Then we'll put pins in there and we'll re-drill those holes, and then we're going to come around and countersink on here for the corbies as those fit in. Okay. I need to know what the next size drill bit is for these. A few thousand bigger. Look at my USAKnifemaker drill chart, and that was a 3/32 drill bit that we used for this hole. The next size, and that's a 0.0938 thousand, is a traditional 3/32. The next bigger size drill bit is a wire drill bit, and that's a number 41. You can see that right in the chart here. These are all over the place online. We'll send you one if you ask for one. All right, we've gone through and reamed out by these holes that we drilled originally. We went to the next bigger size drill bit. The reason is this material tends to shrink back down. Wood will do the same thing, and we wanted to ream those pinholes out a little bit. Now, if you leave a pin in wood or other natural material and it's that tight, like you've seen how tight a fit some of these were, it may not crack that day, but it's going to crack eventually. So you want to make sure that the pinholes in your pin material isn't putting a lot of stress on that, and get that out of the way. So we've got that, and we should be able to get a pinhole. You can see the pin material goes through quite a bit easier now. Since we've got 4 holes in here, we'll see how they index. And it's still a little bit tight, but a lot better than it was. And again, real easy tap. So you can see that fit is a lot better. You don't want a lot of pressure on these pins in the hole. If you got to really pound those in, this material is going to crack at some point, given humidity changes, temperature changes, age. Eventually it's going to crack. So usually you want your pin material to almost float in and out. So we've got that. Now we need to make some countersinks for our corbies on that little ridge. Again, the smaller diameter, and we want a countersink for that larger diameter. What we're going to do is we're just going to kind of eyeball. We're going to take a drill bit that's appropriate for the larger diameter on these corbies, and we're going to drill it down about halfway. And we're not going to get fancy with any measurement or anything like that. We're just going to drill it down halfway and call it good. Then we'll sand off the excess. So let's go countersink these. Now, one thing I want to do, and I've done this a dozen times or more, maybe 24 times. I've got these holes drilled exactly how that's going to fit, and now I'm going to put them and trial fit everything back together. I'm going to use a marker, and I'm going to mark inside and outside, so there's no possible way I can countersink the wrong side and ruin a set of scales. I've lost count how many times I've messed up and drilled the wrong holes on the wrong side. I've just learned to always mark my work. So let's go ahead and get these fitted. One of the things a folder guy will do is when you're making folders, it's all about fit and finish on folders. Folder guy will take together, put a knife together and take it apart 50, 100 times. Fixed blade guy doesn't do it quite as often because he doesn't have that need, but it's a good technique and a good practice to get into, and you should always trial fit your work and make sure that everything's going and lined up like it should be. Now you can see that I've got a light color and a darker color. That won't matter at all on this as we go through, and we'll get it all sanded out. My concern is I want to get everything lined up like it needs to be right now. I'm going to trial fit it, I'm going to mark it, and then I'm going to disassemble it, and then I'm going to countersink the outsides of these scales so the Corby head can be countersunk and put in there. All right, all the pins came through, nice tight fit on there, and let's go ahead and mark that. On a knife blade, the face, the maker's mark side, the point goes to your left. So this would be face in reverse or obverse, okay? So my practice is an arrow that way, an arrow up, and I'm going to call that the left side, because as I look at it, this is my left hand. I'm going to put that way. Another set of arrows. I'm going to just call that the right side. Now that all those magic marker, we'll get that all ground off, and that won't show up when we're done. But that clearly shows what side you're working on and being careful with. So now we're going to disassemble it and countersink 2 holes for Corbies. We're going to put Corby holes right there and there, and then we're going to leave pins up front so you can see both techniques. Okay, now on this particular size with these micro Corbies, that's our name, the major diameter, the larger diameter is 0.120. So that's going to call for a 1/8 drill bit, which is 125 thou. Okay. Again, we're going to eyeball on this. We want to get that Corby head countersunk just a little bit. We don't have a lot to work with. It's only 3/16 thick. So let me get kind of a eyeball there. If we go all the way through, we're going to go through and we're going to lose the advantage of the Corby. So we're going to go just about that far and about right there. Now a lot of these drill presses will have stops or different ways to do that. We're just going to kind of eyeball it and call it good. Okay, we're going to drill just enough to countersink that major diameter halfway through, and that'll hold it. There'll be a little bit smaller diameter inside, larger diameter, and it will hold that Corby in place. We're just doing it by eyeball. So nice and slow, peck, peck, halfway through. And that's all we're going to need. Just enough for that Corby head to countersink in. and it will hold that in place. Let me take this apart. That's going to go all the way through. Tap that in. And it's going to be countersunk right on there. You can actually see it's coming through in the minor diameter, and the major diameter is holding that in. Now when we get the knife all assembled, we'll just simply grind that flush and it'll look like a nice pin. Now these come with a screw shaft slot drilled in for a regular straight screw. Okay, we have our Corby holes countersunk there and there, and we'll trial fit our knife again, make sure all the Corbies go together, they screw together well, and paying attention to our markings, and trial fit it all. Then we're going to come back and clean off the front of that bolster. When you do the front, or this really won't have bolsters but rather scales, what we'll have to do is we'll have to clean up the front there. We have to finish and round that off, taper it, polish it, whatever we're going to do to your choice. You have to finish this part first off of the knife, then you fasten that on, because it's impossible to finish once it's fastened to the knife. Okay? Okay, they fit together better now. I had to go back and drill a little bit deeper. So now we're just screwing these together, and it's drawing the scales in tighter. Again, these have slotted screws on both sides. Nice and tight, and that's the advantage of Corby bolts, is there's just enough material there where that'll actually hold that together. Now you could, if you wanted, simply remove the excess, filing, sanding, grinding, however you wanted. You could call it a day. Also, we're going to come back and put these pins in, and we'll get those through. All right, we have the knife trial fitted together again. Got the Corbies in there. They're snugged up all the way. We've got our pins where our fake bolster is going to be. We're just going to put those in to demonstrate the difference. Now, obviously, that material, the scale material, is sticking up into, it's in the way. So we're going to have to remove the excess, and what we want to do is finish the front of this. So we're just going to kind of eyeball that a little bit and draw a line. And we're going to round that off. We're going to cut that extra off, or grind it off, or sand it off, or whatever your method is. We're going to remove that part and put that back together. We'll do it both sides and finish the front. Then we're ready to glue up. This doesn't have to be very precise. We're just taking off excess material, and we'll go to the grinder and clean that up. This is the Uber grinder. It's new to market. It's pneumatic. This is run by a compressor for the belt tension. Change that belt. Turn on the lever. Got our belt tension. Our first batch of these sold out before we even got them listed. We're getting another batch made. We'll have these online pretty soon. So what we're going to do on, again, these scales, we've got them pinned together so the holes line up. We're just going to finish off the contour up front and round and bevel that off. Again, because we can't do it on the knife. After we get it on the knife, we finish it up now. Now in order to get a nice smooth contour on there, I constantly keep it moving, and then I'm going to round off the corners, and I keep that moving the entire time I'm in contact with the belt. I'm paying attention, I'm looking down here and seeing where that's going. Now my Carta isn't good to breathe. We have a vent fan right there out of frame that you can't see. Normally I would wear a respirator, but you can't hear me talk through a respirator, so for this quick demo here, we're going to go through here. I really recommend that you wear a respirator anytime you're grinding anything. Pretty much got all the material removed. It's even. I'm looking down here and I'm seeing the same smooth round over that way, same smooth round over that way. I'm going to just leave it at that finish. Now this is just a choice, but I'm going to leave the rest of it fairly rough. This is 80 grit belt, and I'm going to leave the rest of this pretty rough, so I'm going to leave that kind of rough also, and that'll fit in. So we've got the front all finished off. Nice smooth round look there, both this way and this way, if you see in the edges there, and the sides match. That's real important as you look here. The round over matches this side and this side, because once you get it on the knife, there's no fixing it. We're going to have one final check, trial fit, to make sure all the parts go together just like we want them, to make sure the front of that looks just as we want it, and see how it all goes together. So let's trial fit this one last time, and we're just going to use the pins this time. We already know the Corby bolts are located properly. Basically I just want to see that that all goes together, and that line right there works. We're well back, we're plenty good there. So now we're going to get ready and glue this up and get it all put together. Okay, the trial fitting all of the pins, the 3/32 pin material, has beat it up pretty good with the vice grips and the pliers, and it's bent and all of those things. So we're going to grab a couple new pins for assembly there. And what I'm going to do is I'm going to take over at the grinder, I'm going to put a little notch or two right in the middle of that pin. I'm going to just cut it through about halfway, just on the edge of the belt. I'll just touch on that and I'll show you how to do that. The idea is that when we glue this up, some epoxy is going to get inside of the pinhole, and it's going to provide a mechanical lock by that epoxy flowing into those little groove notches and holding that in place so that pin doesn't fall out. Pretty easy to do, and it's just a way to safeguard to keep your pins in the material. Just a couple quick notches right in the middle. If I put it at the end, it's possible that I'll grind it away and I'll have a gap showing at the end of the pin, so right in the middle. You're not going to compromise any strength. It will just hold it together better. You can see the notches right in here that we put, and we're going to make sure those get centered in our sandwich when we get that put together. All right, we're going to use 5-minute epoxy. This comes in 5-minute, 15-minute, and 30-minute. 5 minutes, pretty quick. You'll have about 2.5 minutes working time on this. So you just mix this by volume. Just use your eyeball, put it together like that. I tend to use these little sample cups and craft sticks. You can use whatever you need to. I have all the parts laid out, got my clamps ready. 2 minutes is an incredibly short amount of time if you run into any problems. Now, I've trial fit this knife together a couple times. I know it's going to go together, but I'm still going to be pretty close on that 2-minute assembly time. So everything's ready, good to go. Let's get it going. You want to mix this epoxy together, try and keep the air bubbles out. That really, it's not going to be a big deal if you get some in there. It's just going to come out later. Give it a good 30 seconds or 1 minute mixing. You want to get the resin and the hardener all put together. One bottle is resin, one is hardener. I'm wearing gloves because chemicals kill you over 20 years. They kill you slow. I really shudder to see guys with glue all over their hand, epoxy all over their fingers and that. It's not going to hurt you today, tomorrow, or next week, but it's going to kill you in 20 years. Keep those chemicals off you, please. All right, we're all mixed up. Got the pin started there. I'm just going to put that on there and go from there. Okay. The excess is going to squeeze out. I'm not too worried about overflow. A little bit too much is better than not enough. It does get messy, and after a while you'll be able to gauge how much to mix and how much to put on. A little trial and error. It's not going to be a problem. So we'll get that pretty well spread out. Clock's ticking. I'm going to get epoxy and all that on my blade, and as soon as I'm done clamping, I'm going to get some paper towels and start cleaning off all the excess and the squeeze out. And I'll use alcohol. You can use acetone. I find alcohol, isopropyl alcohol, rubbing alcohol tends to work a little better. I just prefer it. So I paid attention to my markings and getting that all together. Tick, tick. Got one pin that isn't lined up and being stubborn. There we go. If you remember, I had those notches in the middle of the pin, so I've got those lined up right in the center. That little notch will have epoxy in there and mixed in. Now I need to get the Corbies in. Still a snug fit, so just got to tap them in lightly. And there's glue that's come out, epoxy's come out, that's fine. Now let's draw that other one in there. Maybe we should put a clock in the lower right-hand corner as we go through this. I can already feel that epoxy starting to stiffen up as I'm screwing these together. There we go. Wasn't engaging, now it is. Now we've got a mechanical lock with the Corbies holding these scales on. We'll have an epoxy lock, and the epoxy really acts as a sealer more than anything. Of course, it does provide quite a bit of bonding strength for the scales, but it keeps junk from getting up in here. Now you're going to have all kinds of ooze out up here. We don't care about that. We do want to get that part cleaned up. You see that? It's already starting to set up. So this is together. We'll get a couple clamps on here. But the Corbies have already drawn it together, and we just want to get the excess glue cleaned up there using alcohol. Now I'm going to clean the rest of this up, but that's really it for today. We're going to let this sit and cure overnight. Most of this epoxy stuff gets to 70–80% strength within the specified time, whether it's 5 minute, 30 minute, 15 minute, that kind of thing. It reaches full strength after 24 hours. So we're just going to clean off the excess squeeze out here. Anything that squeezes out along this edge we don't care about, because that's going to come off tomorrow as we grind away. We're just concerned about right in this part right there and there. Now I'd suggest that you save your mixing cups and show that. Just set that to the side and let that sit and cure overnight also. And then in the morning you can take a look at that mixing cup and you'll get a real good idea on how good a cure that your epoxy got. All right, we're going to pick this up in the morning. Thanks. Hey, good morning everybody. We ran out of time yesterday in our video. We set up our glue and it's cured overnight, and so we're ready to move on to the next step. These come out looking pretty tough looking when you're gluing them up and getting the scales on. We saved our mixing cup to show that the epoxy got real hard and set up. So that part is good. Now cleanup. This really started to kick off quick, and I just about ran out of time. I normally never use 5 minute epoxy. I always use 30 minute and do a glue up at the end of the day. 5 minutes is a really short amount of time in getting a glue up set up. We were trying to get the video done yesterday, couldn't, so we tried with that 5 minute. Normally I'd use 30 minute, I'd suggest you do too. When we ran out of time, we, as far as cleaning up, traditionally use a craft stick, break it, get that little jagged edge there, and I'll use that as a little scraper in here, along with rubbing alcohol and some shop towels, and clean up all in front of the front of that scale and get all that up and there. So after we shut down video yesterday, I spent another 5 minutes just cleaning up the blade all along here, using that as a scraper to get out along there, and we're ready to go on to the next step. Basically, we've got these pins sticking out right here, and we're going to cut those off. We could grind them off or we can cut them off. I prefer to cut them off. It doesn't generate so much heat and melt the epoxy that's in there. And we've got just these little Corbies sticking proud there. So first step is we're just going to remove that little bit of metal that's sticking out there. Then we're going to come back and remove the excess, in this case canvas micarta, around the profile. We'll kind of rough that up a little bit. We want a grippy surface on this particular material, so we're going to use a pretty rough belt. We'll get that rounded off and get that. We're about 10 minutes away from being done. Okay. All right, we've got the excess metal trimmed off. We just used the bandsaw. You could use a file. You could actually grind them off if you wanted. I prefer to keep the heat low. Now, I've been pretty casual about this blade. This isn't a finished sharp blade yet. This is down to about a 15th thou. And I've been careful about not getting it scratched here. What I probably should have done in the first place, and I am going to do now as we move into this next step, is tape over the blade and protect that from the grinding process. Just any kind of bump. I don't want any scratches on here. I don't want to have to clean that up. Normally the first step I would take on working with one of these is to tape the blade up. But this particular model isn't finished sharpened yet. Some of our others, most of our others are finished sharp, and that automatically you'd want to tape up. So what we normally do is we use this blue painter tape and wrap that around. This can stand for days. Sometimes you start a project and don't get right back to it. Regular masking tape will etch. The glue etches into the metal, that kind of thing, and really stains it. It gets to be impossible to move. This blue painter's tape works really nice for knife makers, where you can get it on a blade, walk away from it for a while, and then it removes easily later on without leaving a bunch of residue and cleanup extra that way. So we've got that. Then just a little bit tougher for a grinder bump. Now a grinder will go through this in a second. If I was really concerned about bumping this and keeping grinder rash away from the blade, I would actually take a piece of metal, tape that as scrap metal, and 2 pieces actually, sandwich that over the blade and then tape that on there, so if I did bump it on the grinder, and you'll see what I mean here in a bit, it's not going to get into the blade. And if I had a lot of time into a blade, I'd certainly do everything I could to protect it. What we're going to do now is go remove the excess handle material and then round it over, rough it up, and we're done. On here I'm just cutting away using the bandsaw, just cutting away some of this excess material just to keep the dust down in the shop. So I'm avoiding bumping into the hard metal of the blade and just taking an estimate where it's at. And I bumped into it there. I've put on a Metalite belt from Norton. We're pretty happy with these. They're actually a high performance AO belt on the lower price side. They work good for metal. The value's really surprisingly good on these. And for a man-made material, phenolic, plastic, that kind of stuff, it tends to clog a belt. This particular belt just eats this stuff up and really performs well. So we've got a 60 grit mounted up, and we'll go ahead and remove some of the excess material on here. Okay, I've got most of the contours and a lot of this material hogged out of here. Now, I'd remind you that you don't need a real fancy grinder like this to do this. This can all be done by sandpaper or files, by hand, simply using the tools we have around here in the shop. To save a little time, files, sandpaper, all that will take a little bit longer. You'll still get the same results. Now, I've got most of the material removed. We can actually grind up to and touch on the metal there. This will remove the metal. If you push hard enough, you could take all the way down. So you just basically touch and get that flush there. We're going to put the small wheel on there and onto here and get those contours. Small wheel really makes quick work of getting those contours in. This happens to be a 3/4 1-inch wheel. Usually a 3/4 is the most common. for a finger notch right in there, and it just cleans out the profiles, gets in the smaller contours. They're just handy as a pocket. And how to change these out. The beauty of these is they come in and out, and you can get different diameters. We've got 2 different versions of these, and for different contours, different things like that, you can get in. By far the most popular is 3/4 and then 1 inch followed up. That's traditionally the typical size for a finger groove. Now we're real close to being done on this. What I'm going to do is just clean up around here, get around and just kind of round that off and rough that up. Most of this is going to be kind of flat for there in a bushcraft style knife like this. Traditionally they're smaller, they're lighter, and the handle's thinner. Now it's just totally a personal choice. You could put 1/8 inch material on here. This happens to be 3/16. 1/4, 3/8, just as big as your hand, or it's pure aesthetics or function for you. So just in keeping with this style of knife, we suggest a 3/16 thick handle, and we'll work on getting that rounded over and just about done. Now I've rounded over quite a bit here, and we're going to switch this tool arm out to a slack belt in just a second to finish this. But I've paid attention to the amount that I'm rounding over, and I want it even on both sides. I want symmetry all along the top this way, all the way to the tail of the blade there, and make sure that you have some symmetry in there. So we're going to switch out the tool arm to a slack belt, and we'll put a J-flex belt on there. And a J-flex is quite a bit different. This is an X-weight belt, and X-weights are really stiff. A J-flex is going to be a lot smoother, rather a lot more flexible. J-flex, and that will work around the contours of the blade, and I'll show you how that works in just a minute. We'll get a toolbar changed out, and we'll switch over to the J-flex. Okay, we have a slack belt arm booted up, tool arm, and that's basically just a big open area. We have a 2-inch wheel and a 3-inch wheel there, poly wheels, to give us different contours if we want to touch it on for different contours on different blade builds. Now this is a Hermes belt. The Hermes rep stopped by and dropped off some J-flex belts for us to try. So far we've been real pleased with the Hermes line, and we'll probably be adding this in, and so you'll see this in our listing. But we have an 80 grit J-flex. Now you don't need a fancy grinder. This one is $1,900 with the variable speed motor, brings it up to $2,600. And then with the tools, wheels, that kind of stuff, you don't need that. You can use most any kind of grinder that you have. If you have some woodworking tools, that will probably work. The funny thing is, if you're working on wood, this is called a sander. If you're working on metal, it's called a grinder. It's the same tool. There is some design differences in some different things. With the 3-wheel setup, or a 4-wheel in this case, 1, 2, 3, 4, or 3-wheel if you have the tracking wheel, drive wheel, and the traditional single contact wheel. And the toolbar designs on a lot of these metal grinders that you see in the knife business. You know, you don't need that right away. You can get started with sandpaper, files, that kind of stuff, whittling knives, whatever you want to do if you're going to make this out of wood. So this is later on in your knife making career, or if you want to just jump in with both feet, there's lots of grinders out there. This one's the Ubu grinder by Brian Fellholter, and we'll be having those listed. They're not even available yet. We're getting them listed. They're getting them manufactured, and we're just using it here in the shop to get familiar with it. So we've got this slack on there. Tighten up the belt, and we're just going to round this off, and we're just about done. Now, one of the things that you'll see on these J-Flex is the beauty of these belts is they're really soft and they flex in, and they go around the contours. Now, you still have to pay attention. You got to keep moving. You can't, if you sit in one spot, you're going to get a flat spot. So as I'm grinding, I'm constantly moving. I'll be rotating the blade this way, and I'll also be sliding up and down. And I'm watching the whole time. I'm looking down, as you can see, and watching that material being removed, and I'm paying attention to how even my lines are grinding away, and I'm just trying to get a little bit of a contour in there and take the rough edges off and the hot spots in your hand and get that done. So that's what we'll be working on. I'm varying the pressure, varying the speed, rounding that off a little bit, taking advantage of that belt as it flexes to clean up and to contour a little bit more around that finger grip. You can see where I've touched several times with the belt where if I didn't have that tape on there, definitely would have scratched up the blade. Now you could do, again, hand sanding. I would tell you that it's real easy to get into the machines, and I love tools. I get as many as I can. I take it as far as I can, but ask any veteran knife maker that's making a living off of making knives. You'll find that they can only, they'll all tell you that when you're working with a higher end knife, and the better the fit and finish, the more hand finishing they have to do. It's not a matter, you can only take a machine so far, machine finish, but the really great knives, the awesome finish, the high-end knives, you'll talk to those makers and they'll all tell you that as they get better, as their knives get better, they will do more hand finishing than machine finishing, because that's where the craftsmanship comes in. Now, this is a quick and easy bushcraft knife, really simple. We don't have any metal bolsters, we don't have anything like that. So we can take this just about all the way with this machine and using the J-Flex. But I'd tell you that I do more hand finishing on my knives as far as time, shaping, sanding, that kind of thing, than I ever would on a machine. I want to get that grind line on the top of the spine. I want to even that out, so I'm making a quick, even movement. I don't want any ripples or touch marks in there. So I'm just making a nice, quick, easy pass on this, and this is with that rubber contact wheel. And we've already got that. I paid attention when I did it earlier with the small wheel. One quick, smooth stroke, so we didn't have a bunch of odd ripples or scratch marks in there for a finish. Now, again, you would do this. I would finish this by hand sanding. If this was a higher end knife, we're just doing this for the sake of this video. We'll let you take that as far as you want. So we've got a nice finish there. We're done. Let's unwrap it and see what we got. All right, we got all the tape taken off. we can see that brown canvas in this particular case, micarta. If you look close at the Corby bolts that we used in there, the screwdriver slot is all gone, and it looks like a traditional pin that's in there. Then the pins that we used up front where a bolster would be, just to demonstrate the different techniques, we didn't have to use those, but we chose to, show slightly smaller, but it gives it a sense of style, and we can see that that's in there. Now, canvas is naturally grippy. It's a heavy cotton in there. It's a little bit lighter than we like, so typically on most canvas you'll find a lot of guys will use mineral oil. This is ballistol, and it's mostly mineral oil. It's non-toxic, and this will absorb it. And get all that cleaned up. And we don't need to oil the blade, but we did because it's 440C. It's not going to rust. And that mineral oil darkens the canvas, gives it a nice look. There you have it. Nice little bushy, and really easy to put together if you're just getting started, or if you just need to knock out a bunch of quick knives for some buddies. And then that you can really, from start to finish, depending upon your tooling, your equipment, that kind of thing, anywhere from 15 minutes if you're to a couple hours, depending upon what your finish level wants to be. So, hey, thanks for your business, thanks for your time. Stop by knifedogs.com. Share, learn, network with thousands of other knife makers. This has been Tracy. Have a good one.